Hi guys, welcome to our lesson. So today we're going to be looking at revising functions, right? So we're going to look at a quick recap of basic concepts that you need to know about functions and then try and answer some questions at a later stage. But for now, let's just jump right into it. Now remember that in the types of functions we have, there's 4 of them. And the most important thing is notation, because we normally now use the f, the g, and the h to represent functions. The very first function that we need to look at is the quadratic function, which we know that is a function of the form f of x is equals to ax squared plus bx plus c. And we know that the a, the b, and the c are constants, right? And the graph of a quadratic function is normally called a parabola. That one we do know. Now, the quadratic function can also be given when we know what the turning point is, right? And the turning point is normally the p and the q. So that becomes a open bracket x plus p all squared plus q, and where the p and the q are the turning points of the function. So this is normally the turning points of the function. Now just to look at a specific question, right? To sketch this graph, but before we do that, I want us to look at something very interesting about a parabola, right? So if we look at a parabola here, you can see that I've given you the equation where I know what my turning point is, right? Which is x plus p all squared plus q. Now we're going to play around with these values. We know that the value of a, according to what you're seeing on the board, is 1. My p is 0. My q is 0. Why? Because this is the parent function, which we normally call it. Now, the very first thing I will do will be to try and play around with the a value so that we can see what happens, right? Remember we said when a gets bigger and bigger, the graph gets narrower and narrower and narrower, right? It becomes close and close to the y-axis. But now, when it gets to being 0, it's now a straight line, right? Because it means everything is just multiplied by 0, which is then y equal to 0. It then moves on to a negative, and as it moves on to a negative, you know, that's where it now becomes a sad face, right? Remember happy face and sad face. And the turning point, though, is still at 0. Why? Because q and p are both 0. Now, if I play around with the p and the q now, so I'm just going to take this down again, and I make it a positive. If I make p to be equal to a probably positive 2, you can see that this means that it was shifted 2 units to the right, to the left, where it will then be x plus 2, which means that the new turning point now is at minus 2, the x value. With the q value, I can also just play it with it rather and make it 3, right? A whole number. It means it was shifted 3 units up. So in simple terms, the value of a is 1, the value of p is 2, and the value of q is 3, right? And that's what the function will look like. But now, looking at the one that we have, because we need to know how they move from one function to the other. The negative already tells us that we're dealing with a sad face, so we do know that. So a is equals to minus 2, which simply means that this is a sad face, right? And then my p value is 1, so meaning x is equals to minus 1 is the x value of the turning point, right? And y is equals to the q value, which is 8, and this will simply be the y value of the turning point as well, of TP. So roughly, you can already see that this is going to be a sad face, and with it being a sad face, where it is turning, it must be at point minus 1 and 8. So what exactly did they do from that graph when I was showing you the simulation? It means A was then reflected about the x-axis, hence it became a negative, but it was 2. We can take it as it was 2, and now it's negative 2. And this was shifted 1 unit to the left, because now it's no longer at 0 as x, it is now at minus 1. And it was shifted 8 units up. And when you draw your graph, it will then look something of this nature. So this is normally actually for a positive one, where this is not reflected, but the actual correct graph, because I wanted you to see how the reflection takes place, will then look like this, right? And then you can always just look at what are the intercepts with the axis and what are the intercepts with the y and the x-axis, I mean. So going back here, for me to draw this graph that I am talking about, this will then be y is equals to negative 2, and this was into x plus 1, remember that, and it was all squared, and it was plus 8, right? So you can see now where the graph is, right? So maybe let me just take this away, and this is how the graph will look if you wanted to look at the actual simulation. So if I play around with my values, you can see that it will just change what the P is, the Q is, depending on your shift. This was shifted 1 unit to the left, 8 units up, reflected about the x-axis. And then what is the equation of the axis of symmetry of this? The axis of symmetry is normally the line that cuts the graph into 2 equal parts, which is 2 halves. So it is actually the x value of TP, right? So it will be x is equals to minus 1. And then the domain of this function, remember, just remember that this is actually supposed to go down that way. The domain of this function will then be x is just an element of real numbers, right? Remember, with a parabola, all real numbers are valid. The domain of this will then, the range of this, will be, the maximum point is at 8, right? Because it is actually turning at 8 and not really the way this one is, because this was not reflected. I wanted to show you the reflection itself. So the maximum point is at 8. In simple terms, it means that y, number 1, it must be equals to the 8, right? But also, because 8 is the maximum, it needs to then become less than that 8. So all the values that are less than 8 will satisfy this particular function, including the 8 itself. A different type of a parabolic function or a quadratic function will be x squared minus 3x minus 18. So here I will want you to find the x-intercept. Remember, for me to find the x-intercept, you let y equal to 0. So this will then be 0 equals to x squared minus 3x minus 18. If you want to solve this, you know it will be x minus 6 into x plus 3, right? And that will be 0 there. And therefore, your x-intercept will be x is equals to positive 6 or x is equals to minus 3. Now we know that when you talk about coordinates or intercepts, we normally write them as coordinate pairs. So it will be 6 with 0, and it will be minus 3 with 0 as well. And that's how you will then write down your x-intercept of this function. The turning point of this, there's a formula for that which you are familiar with. This is minus b over 2a. So you know that's my a there, that's my b, and that's my c. So this will be minus into negative 3 divided by 2 into 1. which will simply just be 3 over 2. And then you can take this value and sub it back into the original equation in order to find what the y value is. So that will be h of 3 over 2 is equals to 3 over 2 all squared minus 3 into 3 over 2 minus 18. Then you can just press your calculator on that. It will then give you the y value. The last thing will be to sketch this graph. And to sketch this graph, we know this is a positive, so it's a happy face. It is passing through negative 18 there as the y-intercept. So the graph will then look like this, right? Where the turning point is actually at this point here. Now, I've shown you two graphs of the same function, right? Which is a quadratic function. One where I know the turning point and one where I don't know the turning point. You just need to make sure that you know how to find the turning point if you are not given the equation that shows you what the turning point is, which is the formula that we just used now. And then x-intercept, you know that will normally be if it's in standard form, which is ax squared plus bx plus c. And the x-intercept, you just let your y be equal to 0. And then you will solve your question. So just make sure that you grasp that. At a later stage, we'll look at more questions from past papers to see how do they actually ask these particular questions. But for now, I want us to go grab a glass of water, just take a walk a bit, and then come back refresh so that we can look at some more functions together. Please stay tuned. Hi guys, welcome back to our lesson. So we are still looking at functions, right? And this is mainly just to revise those functions. So now we're going to look at a hyperbolic function just to revise what it is about, and an exponential function just to revise as well what it is about. And then remember as well, at a later stage we'll look at some more questions that have to do with past papers that are asking the same questions under functions, but from the exam type of situation. So let's have a look at it. Now, a hyperbolic function, as we can remember, this is a function of the form f of x is equals to a over x plus p plus q, and we know that the p and the q are the asymptotes of the graph, which are normally shown using a dotted line like this, right? So where the P is the vertical one and the Q is the horizontal one. And this graph is normally called a hyperbola. Now, the very first question will be to sketch this particular graph, right? And to sketch this graph, you can already see that this graph is a negative there. Now, for it to be a negative, we need to quickly see what that does for us, right? If a graph is a negative, firstly, I will start with it as a equals to 1 there, as you can see. As soon as I make it a negative, it changes where it was in terms of the quadrants. It is now in the second quadrant and the fourth quadrant because of the negative. So already that gives us the idea where we are going to place our function. The value of p, if I move it to be a positive, you can see this simply means that it is shifting. Okay, so this is actually supposed to be plus there because we use a plus. So if I am shifting this that way and making it a positive, I am actually shifting it to the left-hand side. And as soon as I make it a negative, I then shift it to the right-hand side. So with the function that we have, let me quickly just check. It was a minus, so it means it's to the right because it's now a negative. So it will be minus 3. Let's make it minus 3 there. And this is also negative 3, so I'm going to put it there. Nope, just minus 3. Yes. And then we also have the value of Q, which we quickly need to check as well what it is, which is 1, right? It must be a positive 1, so it means I'm taking it 1 unit up. So that becomes there at 1, and that's what my function will look like, right? So it was the original function, which was at the center, and it being the center meaning the origin, right, on either side of the origin. I then reflected it about the y-axis, where it then changed the sign and it became a negative, which is the second quadrant and the fourth quadrant. And then I shifted this 3 units to the right and then 1 unit upwards. So to answer the question, sketch this particular graph, it means our graph will then look like this. Now, you can see that on the diagram I did not show the asymptotes because I wanted you to see how to actually do that. So you will take your ruler, you can see that at positive 3, because it was moved 3 units to the right, that's where the first asymptote will be. So you're going to draw a vertical line, dotted line that is going down that way to indicate the vertical asymptote, and then positive 1, which will be a horizontal line like that. And that's where our asymptotes are going to be. So you'll write here x equals to 3, and then here y equals to 1. And then what are the equations of the axis of symmetry? Remember, axis of symmetry have to do with when you are trying to find the line that cuts the graph into 2 halves. So we normally use y is equals to x plus p plus q, right? So that's the first one, and then the second one is normally y is equals to minus x plus p plus q, right? So that's what you just need to look at there. So it means this is the same as x minus 3, because our p there is minus 3, plus 1, which is equals to x minus 2. So that's the first equation, right? And the reason why it has 2 equations, I'm just going to show you now on that particular graph that we first drew. This one will be y is equals to minus negative there, just to work it out, x minus 3 plus 1, which is the same as negative x plus 3 plus that will be plus 4, right? So just remember these 2 graphs because I want to show you what this means on the graph, x minus 2 and minus x plus 4. So remember we said it's y equals to x minus 2, right? So you can see this line is definitely cutting this graph into 2 halves, right? Which is the part below it and the part above it. Then the second line was y is equals to negative x plus 4, right? So the same thing, it is passing through where it looks like it's the center of the curve that we have, right? So we normally have 2 lines of the axis of symmetry of a hyperbolic function. So please do note that. Now write down the asymptotes of f. To write down the asymptotes of f, it will be x is equals to positive 3, and then y is equals to 1. And remember, where I get the positive 3, it's x minus 3 equal to 3, and then you solve for x, which then gives me a positive 3. The domain and the range, the domain is that firstly my x cannot be equal to 3. We know that. But x can be anything else, meaning it can be an element of real numbers provided it is not equal to 3. Also the range, y cannot be the asymptote, which we agreed that was 1, but y can be all the other numbers that are on a Cartesian plane. With the exponential function, remember this is a function in the form of ab to the x plus q, where a, b, and q are the constants, and the exponential function normally has only one asymptote at most, right? So it only has one asymptote. Now to sketch this graph, I'm gonna go back again to my simulation that side, just so that you can see what an exponential graph looks like. Right, so if I move around with my values here, I started with a as 1. If I make a bigger, you can see this becomes a bit steeper, or it becomes a bit stretched, right? It gets stretched a bit more. And then with the b value as well, as it becomes bigger and bigger, that's when it is becoming more increasing. If it becomes a negative, then you know that will not be a defined function, but we know that it can always be between 0 and 1. So it must always be greater than 0. And then the q value will be our horizontal asymptote, but the p value is just a constant. It doesn't tell us anything about what the graph has to do with in terms of where we can locate the graph. So this will then be, to sketch this graph, this is my horizontal asymptote, so I will immediately by -2 draw a dotted line. This is a positive, so it means it's an increasing function, so my graph will look something of that nature, just a rough sketch. But in actuality, it will then look like this, where at this point, that's where my y equals to -2 will be, with a dotted line. And then also, if I'm given this function, the asymptotes of this particular function of mine, we know that will be y is equals to -2, because there's only one asymptote, which is the horizontal one. The domain and the range of this, the domain, definitely x can be anything and everything in terms of the real numbers. So x is an element of real numbers, because x can be 0. If it's 0, it means 0 plus 2, which is just 2, right? But with the range, this y cannot be -2, and it can also not be below -2, because remember that -2 was there and the graph is above -2, so it means y is greater than -2, and that will be what this graph is all about. So we need to understand that the domain of a parabola and an exponential graph will always be x is an element of real numbers, but with a hyperbola, as you saw, there's two asymptotes. So the first asymptote will be what we talk about in terms of the domain, and then the range normally differs with all the functions depending on what function you have. But here specifically, -2 is not part of the range, so I can't include the bar. It can only be greater than -2, and that's how you then answer or write down the domain and the range of this particular graph. Hi guys, welcome back to our lesson. So we're still looking at revising functions, right? Now we're gonna look at questions that are adapted from past papers to just try and see what is the variety of questioning that they use, especially when it comes to functions. So let's just look at the very first question that we have, which involves a parabola and a straight line. So the following sketch shows the graph of f of x is equals to -x squared plus 8x plus 20, right? So you can already see that the graph of f is the parabola. It means the graph of g will be the straight line. C is the point 6 and 32, and EF is parallel to the y-axis. So this makes a 90 degree with the horizontal axis. Now, why is this important? Is because they might want us to find this length here, the length of EF, and since it's parallel, it will be the top minus the bottom, but we will look at that just now. Now, the very first question wants us to find the coordinates of A and B. And A and B, as you can see on my diagram here, these are the x-intercepts of the graph. And for me to find anything that has to do with x-intercepts, my y must be equals to 0. So this will be f of x equals to negative x squared plus 8x plus 20. And this must be 0 because we're talking about an x-intercept, which is minus x squared plus 8x plus 20, which is the same as x squared, because I want my x squared to be positive, so I'm taking it to the other side, or I'm just dividing by a negative. And this is minus 8x, and that is minus 20 equal to 0. Then you will need to factorize this, and to do that, it will be equal to 0 then. It's x and 10, and it's x and 2. This will be a minus, and that will be a plus there. So my x will be equals to positive 10, and my x will be equals to negative 2. So which one is negative, which one is positive between the two? You can see that A is on the left-hand side. So this is the negative 2, and this is the positive 10, not 8. Positive 10, right? So they wanted the coordinate. So it means you'll say A is minus 2 and 0, and then you say B is 10 and 0. The coordinates of D, which is the turning point of this function, we use the equation x is equals to minus b over 2a. Just remember, this is the a, that is the b, and that's the c. So this will be equals to minus 8 over 2 into minus 1, which is just negative 8 over negative 2, and that's 4, right? And then to find the y, it will be f into 4, which is equals to minus into 4 squared plus 8 into 4 and plus 20, right? And then I will want to find what my answer is here. So this will be negative 16 plus then 8 multiplied by 4 will then be 32 and plus 20. Minus 16 plus 32 we know is 16 plus the 20 there will give me 36, right? So that will be the y value. So in simple terms, the coordinates of D, which I want to write them up here so you can see them clearly, will be, we said the x was 4, and the y, we found it to be 36, right? Just always try and verify and use your calculator. And it does make sense because D is on the first quadrant, which means both the x and the y are positive. Now, the equation of the straight line AC, to find that, remember, to find an equation of a straight line, I need the gradient and I need the value of c, which is the y-intercept, right? So remember that. Now, to find the gradient, it will be change in y over change in x. I'm just going to write my coordinates of a here, which I do know is minus 2 and 0, because I'm going to use a and c to find the gradient. So I will say m of AC is equals to y at c minus y at a over x at c minus x at a. And this will be equals to my y at c is 32 minus my y at a will be 0 over my x at c is 6 minus my x at a is negative 2. So this will be 32 over 6 minus or 6 minus 2 will be the same as 8, and this will give me 4, right? Because 8 goes in there 4 times. So already I know I have y is equals to 4x. Now I need the y-intercept, right? And the y-intercept, which is the c, I don't know anything about it. So far, I landed at 4x plus c. To then work out what c is, I can use any of the 2 points. So let's use a, which is minus 2 and 0. If I use that, my y0 equals to 4 into negative 2 plus c, right? And then you multiply there, this will be negative 8 plus c equal to 0, then c is equals to 8. Therefore, the equation of AC will then be given by y is equals to 4x plus 8. You don't really want to write it as g of x or anything, although I had said that, because they did not specifically say that you must leave it in that particular form. Now, this one says we must show that EF can be expressed by that. Now, remember that I said the fact that they said EF is parallel to the y-axis was very important for us to think about, because it tells us that the vertical distance that we need to find will be the y at the top minus the y at the bottom of that particular line. So it will be y at E minus y at F, because E is at the top and F is at the bottom. But you can only do that if they do mention that that line that we want you to find the distance of is parallel to the y-axis. If they did not say that, then you don't even try that, right? And most of the time, it won't even be under this. It will be under paper 2, where you need to use your distance formula and all of those things. But here, it's just y at the top minus y at the bottom. Let me show you what this means. Right, so we said y at the top will be the one at E, and the y at the bottom will be the one at F. So the y at E, I know that, so y at E is actually equals to x squared minus x squared plus 8x plus 20, right? Because it's the value of the parabola, right? We don't know what the actual y is because we don't know the x. And the y at E is equals to, at F I mean, because E we found it, this is equals to y is equals to 4x plus 8. I hope you can remember that that was the equation of the straight line, because this is passing through the straight line there. So if you subtract this, it will be y at E minus y at F, which will then be the same as minus x squared plus 8x plus 20, and then minus 4x plus 8. So, in simple terms, the x squared will remain as minus x squared. The 8 will minus the 4x, which will give me plus 4x. And then the 20 will minus the 8, which will give me plus 12, which is exactly the same as what they said you must show it to be. Now, you need to understand what this word show means, right? To show something means you need to prove. So, in your mind, you are acting as though, or you are trying to imagine it as though you don't know what the answer is, and you need to find the answer. But when you find the answer, it must be what they had given you at the time. That's what show means. It's the same as proof, right? You act as though you don't know the answer. You work it out. The answer must be what they gave you, and that's how you work it out. And this might be one of those level 4 questions that you need to please pay attention to. It's all about y at the top, y at the bottom. If it was a horizontal distance, it will always be x on the right minus x on the left. And that's just how you then find those distances. Guys, I hope you are enjoying this. I just want us to take a quick ad break. When we come back, we'll look at more questions that involve an exponential graph with a hyperbolic graph, just to see how do they pair these graphs and how do we actually answer questions that have to do with them. Please stay tuned. I'll be back just now. Hi guys, welcome back to our lesson. We're still looking at revising functions. Specifically, we're looking at questions from past papers to try and see the variation of the questions that they use there and see how do we answer these questions and the types of things that they normally ask. It has nothing to do with what might come in your paper or anything of that sort. It just gives you an idea of what is the style of questioning that you need to be aware of when you are trying to practice your functions. So right now we're going to look at some exponential graphs that are adapted from past papers and try to see how do we actually answer them. And then at a later stage, we'll look at a hyperbolic function. For now, let's look at the exponential one first. Now, with the exponential graph, it says the functions f of x is equals to a to the exponent of x. Already you can see that this simply means that the value of a must be a fraction, right? Because f of x, you can see this is a decreasing function, right? So it must be, the value of a must be between 1 and 0. Already I know that. And then the graph of g of x, which is k over x, will look something of that sort. So that is the same as your hyperbolic function, right? The other arm we know is normally down there, although I did not really show it here. Now, they said x is less than 0. So x being less than 0, it simply tells us that it is in the second quadrant and the fourth quadrant. But they just showed or drew the one on the second quadrant. If point A, right, which is this one, lies on both the graphs, we need to find the value of A and K. Guys, just looking at this already, thinking about, I have a point, it lies on the graph. I must find an unknown on the graph. It means I do know what the x and the y is at a certain point, right? Even though I don't know what the other variables are. So what I can do is I can take that point, substitute it where x and y is, and see if I will have one unknown, which is the variable that they might want me to find. If not, then I will attempt another method. But for now, let's look at the one of substituting and see if it will actually work. So we start with the graph of f, right? Firstly, it said f of x is equals to a to the x. We know that a lies on this point, on this line, on this curve, I mean, sorry. So it's a, which is minus 2 and 9. So my x value, you know, will be minus 2. My y value will be 9. So this is 9 equals to a to the exponent of minus 2. And if I want to simplify this, it will be the same as me having 3 squared is equals to a to the exponent of minus 2. But I definitely cannot then drop my basis or drop my exponents because I'm thinking I'm having the same basis or the same exponents. There's nothing that's the same here. I want to make it the same. So to do that, I will make it 3 squared is equals to 1 over a all squared, right, in order to get rid of that negative. Then I will know that my 3 will be equals to 1 over a because my exponents are the same, which will then make a to be equals to 1 over 3. Excuse me, remember what I said. I said a must be between 1 and 3. Is it between 1 and 3? Definitely. So that's what the value of a is. Then the value of y, of k I mean, we'll use the same coordinates of a to try and see that value. So g of x is given by k over x, and we know that x is less than 0, right? And knowing that, we also know that we have a point A which is minus 2 and 9, right? So this will simply then mean that the y value is 9 is equals to, the x value is minus 2, so that's k over negative 2. I solve for the k, it will be k is equals to negative 18, and then that's where you end it, right? You can always just end it by writing the equations. It's entirely up to you, where you say g of x is equals to minus 18 over x, right? With the previous one, you will say then it's 1 over 3 to the exponent of x. Now, if the graph is reflected, right, about the y-axis to form the graph of g, you need to determine the graph of h in the form of h is equals to, right? H of x is equals to. So the graph of g, remember we said this was the same as minus 18 over x, right? And provided that it's minus 18 over x, if I want to reflect this about the y-axis, it means I'm changing the x value sign and make it a different sign to whatever it is at the time. So I have g of x is equals to negative 18 over x. It means that h of x will then be negative 18 over negative x, right? Because the x was a positive, but now when we change the sign, it becomes a negative, which will simply just be 18 over x, and that will be the h of x. When they say to you in the form of, it means your answer must be left as h of x is equals to something. And then if the very same graph that we are using, which is g, and we are reflecting this in the y-axis now, instead of in the x-axis instead of the y-axis, we want to form the graph of k. This would simply mean that our equation is g of x is equals to minus 18 over x. And to reflect this about the x-axis, it means I'm changing the y. So it becomes minus g of x is equals to minus 18 over x. But I can't have a negative function value or function notation rather. So it simply makes it a g of x is equals to 18 over x, right? But remember, the g of x is actually the k of x, which is the new function that is formed. And this is a positive 18 over x. So if you reflect it in the y-axis and the x-axis, it will have the same effect to the mother function. And then the graphs of f of x and g of x are shown below. These graphs intersect on the y-axis, right? You can see they intersect there, although we don't know what that point is. But now what do I know on this graph? I definitely know that the x is equals to minus 2 will be the vertical asymptote. The y is equals to minus 1 will be the horizontal asymptote. So far, that's what I know, and that's what I'm going to use. So the point of intersection here of these asymptotes of mine will actually be minus 2 and minus 1. Now, the very first question will be they want us to find the equation of this, right, of g of x. So it will just quickly be g of x is equals to a, into x. I know that my turning point is at minus 2 and minus 1. So this will therefore be plus 2 all squared minus 1, right? And then I substitute any point that I can find on this particular graph where I want to know what this equation is, which is where they're intersecting there, right? So in order to find the value of a, so I will need you to then try and see what this point is going to be. And that point will be the same as the y-intercept of the graph of f. And for it to be the y-intercept, it means x will be 0, so it will be 4 over 2 minus 1, which is 2 minus 1. So it will be the y-intercept 0 and 1, which is 1 is equals to a into 0 plus 2 all squared minus 1. If you solve for your a here, it will be 4, a is equals to 2, and then a will be equals to 1 over 2. So my equation will actually be y is equals to, or g of x rather, 1 over 2 into x plus 2 all squared minus 1. And then just the last question will be determine the equation of p of x if p of x is formed by reflecting this about the y-axis. If you reflect it about the y-axis, my x must change. So it means p of x will be equals to 4 over minus x plus 2 minus 1. And then you solve it so that you can remove those brackets there. Right, so that's what you guys need to please look at with these particular questions. Guys, understand that whenever you are given two graphs, wherever they're intersecting is the most important point. Wherever they're intersecting with the axis, especially the parabola, it's the most important points because it's the x-intercept. Wherever it is turning, it's the turning point, the axis of symmetry, your turning point of that particular graph, and your asymptotes. You really need to make sure that you familiarize yourself with that. Guys, I hope you've had so much fun, because I definitely have, with revising functions and looking at the overview of everything that has to do with functions. Please try to use your internet, your textbooks, to try and see wherever you don't understand things, to enlarge your understanding of functions. But from me, the maths doctor, to you, remember, mathematics is food for the soul. Until next time.